Welcome to my algebra class. We're on chapter 9, section 5, and this is the fourth method of solving a system. Sometimes when we get a system and we want to add or subtract, none of the coefficients, the numbers in front of the variables, are identical. But we could multiply one or both equations by a number of numbers that would make them the same but with different signs. So we could just go ahead and add. So looking at this first one, I have 4 and 3. I could multiply by a negative 3 and a positive 4, make this 12. Or I could use 10, multiply the top one by 2. I think that would be the easiest way to do it, so I'm going to times the top by 2. You have to multiply both sides. So we have a new equation, same value though, 8x minus 10y equals 46. And then we're going to add it to 3x plus 10y equals 31. So this is 11x, these go out, which is what we wanted to have happen, equals 77. Divide by 11, and we get x equals 7. And then we can substitute back in either here, 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 or here. So I'm just going to take this one right here. So 8 times 7 minus 10y equals 46. We get 56 minus 10y equals 46. Subtract 56 from both sides, and we get negative 10y equals negative 10. And then divide by negative 10, and y is 1. So far for our ordered pair xy, we've got y is 1, and we can plug that back in. Oh, excuse me, where I got 7. And x is 7. Not thinking there. Okay, looking at the second one, there's no way to get the 3 to be a 5 just by multiplying this, or the 4 to get 9, so we're going to have to multiply both equations. So let's go for 15. We could do 36 over here, but this is a little bit shorter. So I'm going to multiply the top by 5 and the bottom by negative 3 because I want to get positive 15 and negative 15. So our new system is 15a plus 20b equals 10, and negative 15a minus 27b equals negative 3. So adding these together, I get negative 7b equals 7, divide by negative 7, and b equals negative 1. And then substitute it in. Generally, these are the easier ones to work with. After you've multiplied them by 5 and negative 3, the numbers get rather large. So I'm just going to plug it into this original one here. 3a plus 4 times negative 1 equals 2. So 3a minus 4 equals 2. Add 4 to both sides, and I get 3a equals 6. Divide by 3, and a equals 2. So my ordered pair is A, B, and it's 2, negative 1. So as I substituted 2n for A and negative 1 for B for both of these, I would get the same. They would solve the system. Okay, with that in mind, we're ready to start doing the assignment. So you need to get a piece of paper headed for 432, written 1 to 18. Skip a line, title, skip a line, fold your paper, and we're on 432 and we're doing number 2. And number 2 is to go back and solve the systems and oral exercises 1 to 9. So number 2, we have 3a plus 5b equals 3, and a plus 2b equals 13. I'm going to multiply the bottom by negative 3. So our new system is 3a plus 5b equals 3, and negative 3a minus 6b equals negative 39. Adding, I get negative b equals negative 36. So b is 36. And I'm going to plug it into this original equation here, a plus 2 times 36. Remember, you can use any of these equations when you go back to find a. So a plus 72 equals 13. Subtract 72 from both sides, and I get A equals 59 negative. So my ordered pair is AB. A is negative 59, B is 36. Problem number 4, going back to the oral exercises. The system is 4x minus 3y equals 7, and 5x minus y equals 6. I'm going to multiply the second equation by a negative 3. And I choose to do that because that's only multiplying 1. Otherwise, I'd have to multiply, if I use the x, I'd have to multiply the 4 and the 5. This equation and this equation by 5 and maybe negative 4. So this is better. So my new system is 4x minus 3y equals 7, and negative 15x plus 3y equals negative 18. Adding, I get negative 9x equals negative 11. Okay, I have a mistake here. This should be negative 11x. Dividing both sides by negative 11, I get x equals 1. And I'm going to substitute it back here, so 5 times 1 minus y equals 6. 5 minus y equals 6, subtract the 5. I get negative y equals 1, so y equals negative 1. And my ordered pair is xy, so x is 1 and y is negative 1. Problem number 6 on the oral exercises. The system is 4x minus 3y equals 8. And 2x plus y equals 14. I'm going to multiply the bottom equation by positive 3. So my new system is 4x minus 3y equals 8, and 6x plus 3y equals 42. Adding, I get 10x equals 50. Divide by 10, and x equals 5. Substituting back over here, I get 2 times 5 plus y equals 14. So 10 plus y equals 14. Subtract the 10, and y equals 4. So my ordered pair for number 6 is xy, which is 5, 4. Problem number 8, which is still the oral exercises. The system is 2c minus 3d equals negative 1, and 3c minus 4d equals negative 3. So looking at this, if I multiply the top by 3 and the bottom by negative 2, I can get two variables, same number but different signs. So the new system would be 6c minus 9d equals negative 3, and negative 6c plus 8d equals 6. These would go out, so that would give me negative d equals 3, so d equals negative 3. And then plugging that back in, I'll just use the bottom. 3c minus 4 times negative 3 equals negative 3. So 3c plus 12 equals negative 3. Subtract 12. I get 3c equals negative, that's a c. Equals negative 15, divide by 3, and c equals negative 5. So my ordered pair is CD, which is negative 5 and negative 3. And on going back to the next page, number 10, the system is 3c minus 8d equals 7, and c plus 2d equals negative 7. I'm going to multiply the bottom by negative 3. So that gives us a system of 3c minus 8d equals 7, and negative 3c minus 6d equals 21. Adding, I get negative 14d equals 28. Divide by negative 14, and d equals negative 2. Plugging that back in here, c plus 2 times negative 2 equals negative 7. C minus 4 equals negative 7. Add 4. And I get c equals negative 3. So my ordered pair is CD, which is negative 2, negative 3, negative 2. Problem number 12. The system is x plus y equals 7, and 3x minus 2y equals 11. Since this y is positive and this is negative, I'm going to use the y's to get rid of those. So I'm going to multiply the top by 2. So that gives us the system 2x plus 2y equals 14. And 3x minus 2y equals 11. So adding those, I get 5x equals 25. Divide by 5, and x equals 5. Substituting in over here, I get 3 times 5 minus 2y equals 11. So 15 minus 2y equals 11. Subtract 15 from both sides. I get negative 2y equals negative 4. Divide by negative 2, and y equals 2. So my ordered pair is x, y, which is 5, 2. I hope by now you realize that the systems have to be written in what we call standard form, ax plus by equals c. Otherwise, you'd have to get them there. 14, we have 2n plus 5a equals 14, and 6n plus 7a equals 10. So we're going to have to decide which one we want to do. I'm going to multiply, I'm choosing the n's. I'm going to multiply this by 6 and this by negative 2. So I'm going for 12 and negative 12. So I get 12n plus 30a equals 84, and negative 12n minus 14a equals negative 20. Adding together, the n's go out, so I get 16a equals 64. Divide by 16, and a comes out 4. Substituting back in, I get 6n plus 7 times 4 equals 10. 6n plus 28 equals 10. Subtract the 28, and I get 6n equals negative 18. Divide by 6, and n equals -3. Our ordered pair is A, N. A is 4 and N is -3. Problem number 16, 3t minus 8z equals 34. 7t plus 4z equals -34. I'm going to multiply the bottom by 2, and that would give me +8. So our system will be 3t minus 8z equals 34, and 14t plus 8z equals -68. Adding those together, I get 17t equals -34. Divide by 17 and t equals -2. Substituting that back into this one, 7 times -2 plus 4z equals -34. So -14 plus 4z equals -34. Adding 14 to both sides, I get 4z equals -20. Divide by 4, and z equals -5. So our ordered pair is t, z, and that would be -2, -5. And our last problem, number 18. We have 4r plus 9s equals 23, and -7r plus 3s equals -34. So I would multiply, probably easiest to multiply by -3 on the bottom. So we get the new system 4r plus 9s equals 23, and 21r minus 9s equals +102. Adding, we get 25r equals 125. Divide by 25, and r equals 5. Substituting, I'll just take the bottom. -7 times 5 plus 3s equals -34. So I get -35 plus 3s equals -34. Add 35, and I get 3s equals 1. Divide by 3, and I get s is 1/3. Ordered pair is rs, so it'd be 5 and 1/3. That concludes the evens. Be sure you check the back of the book for the odds for the answers.